Okay.
It started. Okay. So, which hypothesis test would be most appropriate for this analysis?
Would it be a test of independence?
I would say so.
Yes, I think so.
Okay, so last answer then. I can read number 3. A human resource manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 30 years old or older. They also reported the number of employees in groups who were terminated. They want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for analysis? So there's 2 groups.
Okay,
so
if
maybe
we
like
have 2 groups.
independent sample.
Yeah, could be independent sample actually.
I don't know, because like
they're not related.
They're not related, it's true, but like, how are you gonna do that? Because it's like, you will probably need to do a proportion. Because like, you will have to study it, like, let's say that, because if you terminated like 2 people above 40 years of age, and you terminated 10 people under 40 years of age, but you have, it's like 100 employees that are under 40, and you only have like 5 employees that are over 40. You terminated 2 out of 5 against like 10 out of 100. So it's like, you probably will have to put in relation to the
work as a proportion.
Yeah, because it's just one company, right? So it might be a test of 2 proportions.
Okay, I see your logic.
Yeah, that makes sense. Okay, let's go for that. Question 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? So I think so we know the proportion. Well, so we're just looking to find one proportion, right? Because the other one, we already have it, and we want to
yeah,
know.
right. I think you're right. Because we already know one is 48.5.
So could it be like the test of one proportion?
I'm thinking it could be.
No, could be. Because the other one is already known. Could be. Let me check one thing. Okay. Wow. Need to open another tab.
Yeah, I think so. I think it's one proportion.
Okay.
Just because like, you already have like the population parameter, so you're just gonna probably do a hypothesis test. That's it.
then you want to read the next one?
Question 5. Student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis?
So they're going to compare the two times, like the two average time. Which one will be?
I think so.
That's not very simple. Would be most appropriate.
Oh, no. It could be a paired sample t-test or an independent sample t-test. It's one of the two, probably.
So
What do you think?
for the paired, don't they have to have like conditions where they're like kind of the same? Like it just doesn't seem like they're very like anything.
Yeah, match or.
But you see, it's like it could be the student, you know.
Oh, one
Match. Because like they asked 25 students to do that, each student was given the combination to each lock and asked to open the locks. So I think it's that each student opened lock 1 and opened lock 2 and was recorded.
Okay.
Then the next student opened lock 1 and lock 2. So it could be a.
So we have two set of data.
We have two set of data, but we have each row. It's according to one student.
Yeah.
So it's
yeah.
Yeah.
That's why it could be a paired.
It's related to like before and after. So yeah, I can see how it.
Yeah, and it could be like the whole like lock 1 minus lock 2, and you can see if there is really like a difference or not.
So we'll try for pair sample.
Yeah.
Let's say. Question number 6.
Yeah.
A bank employee.
Wait a second. For the next 3 questions, identify the one confidence interval that is most appropriate.
Yes. So, a bank employs to appraise. What is that? Appraisal?
Appraisal.
What is that? Do you know that word? Okay. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties to both appraisers at recently valued. Which confidence interval would be most appropriate for this study? To make sure this is the case, the bank evaluates 6 properties.
Would it be a nova? So would that be a? Right.
I didn't hear what you said. Sorry.
Oh no, never mind.
Well, it's probably like a paired sample to make sure this the bank evaluates 6 properties that both appraisers had recently valued. So you're checking, you know, the same property, 1 and 2, same property, 1 and 2. So, and then you're making a confidence interval. So I think it's very simple.
Compare samples to confidence interval.
What do you say? Do you agree?
I'm looking for something real quick. My internet's going slow.
What?
Just
Sorry.
a moment.
Okay.
Yeah.
Can you guys hear me?
Yes. Now you
Yeah.
can.
We're not really.
So I'm thinking it would be like the confidence interval that goes with ANOVA testing, but I forgot which confidence interval that is. Would that be closest to paired sample T confidence interval?
I cannot understand what you're saying.
Can you say that again?
Can you hear me? So from the test, from this problem, it sounds like an ANOVA test, doesn't it?
Okay. I don't know, because like ANOVA, you would have more than 2 sets of values, but I think here they will have only 2.
Well, there's 2 appraisers, and there's 6 properties, right? At both appraisers. Oh, I see. So it's like, oh, they both get the same 6 properties, right? So it's like comparing how each one.
Yeah.
Okay, so yeah, I think you're right. Paired sample T confidence.
Okay.
In a Wall Street Journal article, one satisfaction with career path, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study? So we're comparing 2 different no, I need to read that again.
Percentage of psychology majors. So it's a percentage. That means that it's a proportion.
True.
It's not a normal
Career
number.
path was reported. The same data
So
was also
it's probably a confidence interval for 2 proportions.
For psychologists.
So the last one.
Yeah.
Double stuffed Oreo cookies, then you should read this.
Yes.
Yeah.
I love them.
We don't have them in Italy. I'll bring them here every time I come back from the States.
Or when I go to England.
He loves that.
So double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion.
We should have done that
by
study.
the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? I will go with the 1 sample T confidence. Because here it's just talking about the double stuffed Oreo and its filling, you know. And we definitely don't know the population standard deviation, you know. It's like,
yeah.
Well, we could, if they published it, you know, if
the company is actually telling you how many grams or
if what's like Nabisco
quante le calorie
would tell, but I don't think that's an accessible thing, and they're not saying it here. So I would go with the 1 sample T confidence.
So in one or in a 1 sample T test, you don't know what standard deviation is. That.
I didn't understand.
In the one sample, two confidence interval, you don't know the standard deviation.
Well, we don't know the
Yeah.
the population parameters. So since we don't know the population parameters, we cannot use the Z test. We need to use the T test.
Okay.
So I'll go with the one sample T confidence because it's actual numbers, it's not proportions, and it's one.
Cool. So question 9. Which one of the following best defines the notion of the significance level? What's that?
No, don't worry.
Of the significance levels of a hypothesis test. Oh, I think so. The probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true. The probability of the type 1 error, the probability of rejecting the null hypothesis, whether it's true or not, the probability of the type 2 error. I will say defines the notion of the significance level of so the probability of the type 1 error. It's just laughing at me. I hate that guy.
Yeah, I agree.
I'll say the second one, but what do you think, Isai?
Just one to find emotions. Yeah, really tough one.
This is really not comfortable when you so I got you out of the
Well, you can still see my ear, so I'm still here.
not comfortable this position.
So you guys said
Sorry?
You guys said it was a second option, yeah?
Yeah, the probability of a type 1 error. That it's the probability of rejecting a true null hypothesis. And question 10, which one of the following best defines the notion of the p-value? And I think it's the third one.
Yeah,
so it's the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null
I'm
hypothesis is
really
true.
confident with this one. I'm sure I learned.
Oh, look at this. Suppose you create a 95% confidence interval for a mean 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean?
I've done this wrong a couple times recently, so he's teasing me for that.
So it should be the second one.
Yeah.
No, wait.
I know I messed this up before, and it was the 95 off 95. I remember that, but
I know it's not D. I think it's A or B, but B sounds like something that would be correct.
So I would answer I would answer the third one, and it was wrong. So it's not. So I should answer the second. That's what happened last time to me.
Well, the third one is wrong. The fourth one is wrong. So it's either the first or the second.
Yeah.
I will go for the second, and then I'll tell you guys if it's.
Well, aren't we saying
Yeah,
that
I think it's.
we're 95% confident that the interval is between 10 and 20, not necessarily that 95% of something means they're 10 between 10 and 20?
Well, we're saying that the true mean is between 10 and 20. So we're leaving 5% of confidence out. So it means that 5% of the confidence interval that we come up with don't contain the true mean. So it's the second one. But I got the logic behind it.
I still don't get it, but I learned it from my previous mistake, and so I'll just put the second one anyway.
It's like we're just at 1/4 of the whole quiz,
There we go. Information. Use the following.
He's like, I see you're really happy.
No.
I'm so hungry.
I feel bad for you guys. It's late over there.
Yeah, and we've been in work council from 7 to just before the meeting, and now we're here.
And in Italy, we usually have dinner after 7. So
Yeah, we usually have dinner between like 7 and 8:39. That's usually when people have dinner.
Wow.
So yeah,
there we go.
we
Simon.
are hungry. So use the following information to answer the next 3 questions. You take a simple random sample of $100 from a town in Western United States. Determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is 30%. What is the mean of the distribution of the sample proportions? Well, it should be 0.30 because it's like
Assume the unknown population proportional.
because there's nothing else that we really can say. What is the mean of the distribution of the sample proportion? Yes, it's 0.3.
0.
What is the standard deviation? So standard deviation is P multiplied by 1 minus P over N.
Allora.
Let's get
So
the calculator.
0.3.
Calculator. 0.3 multiplied 0.7
Yes.
divided 100,
Square root.
and we square root it. Bam. It's
0.04.
Standard deviation 0.046. Did you get the same?
0.
So
0.0.
Okay.
what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
So the value minus the mean over the standard deviation. That should get us the z-score, and then we can use that to get the probability.
Probably, yeah, but
So 0.25.
yes.
We'll do 0.25
Mhm.
minus 0.3, and we divide that by 0.046. It's negative
1.087.
7. And it said the question, the probability that it's less.
Is less than
Minus
0.25.
1 point.
Oh, 0.087.
0, what is it called?
0.87.
Negative 1.07, no?
What?
Yes,
Wait, the probability, that's not the probability.
that's the applet.
That's
the
the
z-score that we put in the probability applet.
Less.
Less.
So the probability is
0.139.
0.139.
Use the following information to answer the next 7 questions.
Did you say 0,
Yes.
1, or 0?
0.139.
Yeah.
Okay, so next information. Use the following information to answer the next 7 questions. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into 2 groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Dude, you can have a side effect of a placebo? That's interesting. What an unlucky life.
At the end, probably, they shook those 15 people's hand and said, mate, your life sucks.
You got a side effect without even taking the medication. What a bummer. Okay. Sorry.
Let P1.
Let P1 be the true proportion of people who experience the dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds below rounded to 3 decimal places.
Okay. So P1 are the people from the actual experiment.
Yeah.
So
So
the
we know
people
that
who had dizziness is 61.
Is 61 over 1563.
And the other is 15 over 1563.
Yes.
Confidence interval 95%.
Yes.
It's a 95% confidence interval. And what kind of test are we looking for? For P1
minus P2.
It's a confidence interval, so it doesn't change. For R. Okay. So P1 minus P2. Okay. So what's the margin of error?
Margin of error for this 95% confidence interval is and Excel says 0.011.
Wait a second.
No.
That's stupid.
Yes. Okay, so 0.011. 16, input the lower bound.
0.019.
Lower bound. 0.4. 0.04. Yeah, sorry. Perform a hypothesis test to see if the proportion of experimental group subject who experience dizziness is different than the proportion of control group subject who do. Use a level of significance of 0.05. What are the appropriate null and alternative hypotheses?
I would say it's the first one.
Null hypothesis, yeah, they're the same. Yeah, first one.
Okay.
Is it okay?
Yeah.
The value of your test statistic is, let's see.
Statistic Z, 5.342. like there is difference.
Question 20, the p-value of your test is
0.
0. Question 21, is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril, whatever, is different than the true proportion of people who experience dizziness while not taking Acupril? I failed to assess.
I'd say it's the
So,
the
what's the question?
one,
Is
like
there
before
sufficient
the
evidence? Second to list. Yes, I reject the null hypothesis.
HO.
fifth one.
Sure.
Would it be the third one?
The third one, no, I reject the null hypothesis.
No, because
No, because the
there
question
is.
is there sufficient evidence to conclude that the true proportion? Yeah, the question is there indifference? Yes, there is, and so we reject the null hypothesis. Doesn't make any sense. No, sorry. Is it okay, Isai?
Yeah. So you said it. So not. So which one did you say it was then? Do you think it was?
The second to least one, I don't know how to say it. Yes, I reject
Yes, I
the
reject it.
null hypothesis. Yes.
Different. I see what you're saying.
Okay, so use the following information to answer the next 4 questions. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypotheses for this study are null hypothesis. Being a morning or evening person is independent of age. Alternative hypothesis, being a morning or evening person is not independent of age. The results of the survey are given here. Conduct a test of independence, use a level of significance of 0.05. Question 22 is calculate the test statistic for this hypothesis test. Assume the requirements for the test are satisfied. Okay, so we put that in the Excel spreadsheet and we see the test statistics is 6.579. Then for this hypothesis test, assume the requirements are satisfied. So the p-value is
0.087.
Yeah.
Yeah.
Did you guys get Did you guys get 6.579?
Yeah.
yes.
Manga.
Sport italiano. Segue il calciomercato. Segue il calciomercato. Should you reject null hypothesis or not? Explain.
Maybe the fourth one.
The fourth one, yeah.
Yes.
No, the p-value is greater than 0.05.
What do you conclude based on your results? We have sufficient evidence to say that being a morning or evening person is not independent of age. Sufficient evidence to say that morning or evening person. I'll say the second one. We have sufficient evidence to say that being a morning or evening person is independent. No. So what was the null hypothesis again?
That it's independent.
Okay. And
We never confirm the null hypothesis. We just say
we just reject the alternative.
no. We just say that we don't have sufficient evidence to sustain the alternative. So we have insufficient
Yeah,
evidence
to
to say
say
that being a morning
so
or
the
evening
fourth
person is
one
not
is it
independent.
not giusto. Io scrivi. No, non era lui che alla fine non mouse. Oh, so hot.
I'm hungry. Okay, so man, we still have 20 questions.
Don't worry about it. Don't think about it. Yes.
All right, I can read the next one. It says, a recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period.
We cannot hear you.
Dalle 51,
Okay, sorry, I was trying to.
Can you hear us?
I can hear you guys, yeah.
Oh, okay, yeah, it's just a little bad for us, but it's okay. Don't worry about it.
Okay.
Can I just tell you something? Like, do you know the project we're making about looking at different temperatures between the United States, Idaho, Utah, and here?
Yeah.
The perceived temperature, so you know there's difference between perceived temperature and the actual temperature, because the perceived temperature is also like calculating the humidity level and blah blah blah. So it's like how actually people feels like. The other day, the perceived temperature in a city not too far from us was 120 Fahrenheit. So it's dang hot here, or at least that's how it feels like.
But that's the perceived, you know, like the real one
Would have been probably like metti. Quanto è?
metti 35.
Ah, non era 35. Sì. Ah, 35. Ah, 60 37. The real one was 95.
It's really hot.
Just annoying weather.
Right, can we move on now?
Yes.
Okay.
So, do you want to read the next one? We'll pay close attention.
Oh. Okay, it said a recent book noted only 20% of all investment managers outperform the Dow Jones Industrial Average. Over a 5-year period, a random sample of 200 investment managers that had graduated from the top 10 business programs in the country. Period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Based on the results of this sample, create a 95% confidence interval of P and put the lower and upper bound rounds below to 3 decimal places. So is there like a data sheet? I didn't see it before.
What did you say?
What I'm looking for the Excel sheet that comes with this problem.
Your mic has something wrong, probably, you know, because it's like.
Or is the connection? Come on, just do not insult his mic. You, what a not polite person you are.
Well, so yeah, we use the Excel spreadsheet.
Yes.
And we use the one proportion.
So
we just put like 50 as X and 200
as
N. and the 95% confidence interval has like 0.190 and 0.310.
So for question 26,
Yeah, question 26.
Question 26 is 0.19.
and then 27,
It's 0.31.
Suppose you had been in charge of designing the study. What sample size would be needed to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P equals 0.2 for this estimate.
All right, so we have the formula.
Yes, no c'è, poi non c'è forse.
No.
Okay, I'm on it.
So it's a 95%.
Yes.
What was 95%? 1.96, was it?
1.6.
No, that was the 90%.
Okay.
Wait a second. I wrote it down here. I'm just gonna get it. It's 196.
1.96.
We get 1.96, and we divide it by the margin of error. It's 2%, so 0.02. Then we square that, and then we multiply it by E asterisk, that it's 0.2. And then we multiply that by 1 minus P asterisk, so 0.8. So it should be
1,536. Oh, yeah.
Because you have to round
Yes,
out
yes, to round.
to the whole number.
You don't get 0.64 per person.
1, 5, 3, 7.
Okay.
yeah, 1,357.
No.
1,537.
Amigo mío.
1,537.
Sorry, can you say that one more time?
1,537.
I think I got it.
Okay. Never know.
Suppose I got it on my phone. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs perform better than other investment managers. Conduct an hypothesis test. Use a level of confidence of 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing this question? Oh, addressing? Thank you for addressing this question. We want to, if one does it better than the other one. So I will say the first null hypothesis probably be equal, and the other one should be 2% is the margin of error, so we want that to be smaller. So the second one.
Well, like this is actually the proportion.
Oh yeah, the
that
proportion.
people perform better than
so
the industrial market. So it has to be
it
greater.
has to be greater than 0.2. Yes. What do you think? So we think this is the fifth one.
Because the P would be greater than the the null. Yeah.
Thank you. Yeah, we think P should be greater than 0.2.
Okay. Question 30. I would say it's the first one.
Oh, dude, read it, man.
What
What
requirements
requirements
must be met to ensure P hat is normally distributed?
And B greater or equal than 10 and N and 1 minus P. Yes. We have that in our notes. So the 30th question is the first one. Kilos per kilogram. The value of your test statistic is
So the value of Z is the value minus the mean over the standard deviation. But I'm a bit confused.
the value of your test statistic.
How do I do that if I don't know?
Okay, qua value minimum standard deviation. We know this.
Okay. So we're going back to the original thing, you know?
So standard deviation
Okay.
is 0.05.
Oh wait, so where you see the
Value minus
wish to see if there's anything that graduates. Okay. Yeah. Okay. I just got lost for a moment. Sorry.
so we do isn't this
Yeah.
one? Daniel, isn't this one?
No.
No.
Just a second. So let's go back to the Excel spreadsheet, and the null hypothesis is 0.2. So test statistic
Is
1.768.
1.768. The p-value of your test is
P-value 0. Wait, what's the? It's greater than, right?
let me check. Yes, greater than.
So the p-value is 0.039.
That's what I got for my p-value.
Yeah.
Did you guys get for the Z 1.768?
Yes. Is there sufficient evidence to conclude that graduates from the top 10 business employers perform better than other investment managers?
Yes.
Yes, I reject. What is this? Yes, I failed to
It's
reject.
the first one.
Yes, we just reject. Do you agree, Isaac?
Yeah, just a moment. Let me read that one more time.
Yes. I agree 100%.
So wouldn't your alternative is that they perform better? The other will know is if they perform the same, and you're saying that you reject the.
Well, I don't really understand what you're saying, because it's like the audio is really bad that it's coming from you. But
Yeah.
like, we reject the null hypothesis because like we're saying that like the p-value is 0.039, so it's
Okay.
lower. It means that actually the graduates from the top 10 business schools actually perform better than others. Like, they are performing better. And so we reject the null hypothesis, because the null hypothesis was that they are the same, that the proportion was the same as the population's proportion. But here is actually better.
Yeah.
So, can we go on?
Yes. Yes.
So, use the following information to answer the next 6 questions. Oh my days.
Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based
translation program called Pharo. The quality of the translation can vary. A good translation system should match professional human translation. It is important to be able to quantify how good the translation produced by Pharo are. The IBM T.J. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation understudy. A BLEU score is a number ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. This helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ideas. To compare Pharo's ability to translate with similar computer translation software, Kern took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these in English. The BLEU score was calculated for each of the 100 blocks. These scores are recorded in the data file. He wants to use this data to see his mean score differs from the mean score of another leading translation software, which has a population mean score of 0.295. Assuming the requirements are satisfied, construct 95% confidence interval. So, we have our good friend, BLEU scores again.
It's like the third time or something.
Probably that they come up.
Nice.
So I think that we'll probably have to use that other file, that it's the first one, like quantitative, was it descriptive? No, sorry, quantitative inference procedures.
Alright, right back.
This is the Z-score one, right?
I don't know, because let me check one thing. I don't know, because we don't really have, because to do the the z-score, like we need the standard deviation.
Okay, so it's t-test then?
I'm trying to check just because I don't remember well enough, so I have to check.
Well, I am the solution.
Yeah, sure. Since when?
Since I was born. Answer to all your problems. Around the cause, one of them. Okie dokie. Another man.
Because like the population standard deviation, it's something that, if I remember correctly, it's not something we can calculate.
No.
It's like something
We either have it or not.
that they have to give us.
Yes, we have
So
it
we
or not.
cannot use a z-score if we don't have population standard deviation.
Yes.
So we might need to use the one sample t-score,
T-score, yeah.
t-score, t-test, whatever it is, yeah. So I think that's really what we should be looking at.
Yeah.
Does it make sense to you? Sure, 95%.
So, to round your answer to 3 decimal places, input the lower bound.
So what are you doing right now, Izzy?
Put it into the one test.
The t-test? Okay. Yeah, I did that, so just let me know when you have your result.
So my only question is, what type of test is it?
Well, I think it's
And that's
one sample.
Yeah, it's one type of test, I think. So I got like a lower bound of 0.282.
Yes, that's what we got.
An upper of 0.293.
Yeah.
Exactly.
And then 99 for the degrees of freedom.
Sorry?
Degrees of freedom.
You get 95 or 99.
99 degrees of freedom.
Yes.
This was like the sample size minus 1. Okay.
Input
Test statistics.
Minus.
Is it negative 2.803? Did you put the null hypothesis at 0.295 and the type of test not equal to?
So hold on, let's see. Okay, so it's negative 2.80.
What?
Is that what you said?
Yes.
Negative 2.803.
You guys sound like a third new speaking something.
What did you say?
you know, like in the scary movies, and there's like someone who's possessed, and they all speak at the same time. Like,
sorry, can you say that one more time? Because we can hear like some words, and then
It's just like a squeaking thing, you know.
and sometimes it cuts off the sentence. So
Yes, come in. Cats. Oh. In this game.
Oh.
All right.
Got it. I got scary movie. That was the only word I hear
Okay,
before.
so the p-value, is it 0.006?
yeah, it's
Okay, is that what you got?
0.006.
Good.
That's right.
Based on the results of this test, what would you conclude? Use a level of significance of 0.05. That the true mean is different than.
I would say the first one.
We have sufficient evidence to say that the true mean is different. Yes. Okay. Who's the last?
Yeah, hopefully we haven't missed too many, so that we don't have to come back and redo it.
Redo the whole test. Okay,
Oh,
use the following information to answer the next 6 questions. A study was done to test the notion that people are taller when they first wake up in the morning. Oh, that's something not new again.
We already did that. So taller in the morning, like than in the afternoon.
You want to determine if the children are taller in the morning. Yes. Define the differences AM height and PM height. Construct a 95% confidence interval for the true mean difference of height and conduct a hypothesis test. Level of significance 0.05. To determine if the children are taller in the morning than in the evening, input your answer below. Lower bound of confidence interval. Okay. So I need to copy that.
So which sample are we gonna use?
Paired sample, no?
Paired sample t-test.
I was just trying to get you.
Do you have an older brother?
Me? No.
Yes. No.
You're missing out a lot of blessings then.
In Italian, we say de brutto, like a lot.
Yeah, man. That's the way. The only way. Well, you just shut up. It's better for you, you know. All right, so
not cool. 2 against 1. What can I say?
Input the lower bound of the confidence interval.
Yes.
95% confidence interval.
Yes,
okay.
sir.
My lower bound is
8.728. Is that what you got?
So my data is still loading right now. Sorry, guys.
8.728.
Yeah.
No. We are different. No.
Oh well, we have to check AM minus PM. Let's see if I did that. Yeah, I did AM minus PM, yeah.
Also because you should be taller.
There's not one negative, you know, it's like everyone is
taller in the morning.
Like everyone is
Every
taller.
single one.
Every single one.
That should mean something.
And like at least by 4, is it like inches? Or millimeters?
Probably. Whoa.
At least by 4 millimeters.
Okay, let's figure out. What did you get as the lower bound?
Yeah, just one moment. Okay, so I got lower bounds of 8.728.
Yeah.
Yes, perfect. That's what we got. Well, did you get his upper bound? I got 10 point. Yes, perfect.
And test statistic, I got 22.
0.446.
Yep.
Okay.
The freedom 40.
Degrees of freedom.
40.
Yeah.
Yes.
And the p-value 2.795.
No, I didn't get that. No.
We got 1.38.
Because we're looking at
Oh, is it greater than?
I think it's greater than, yeah, because we need to determine if the children are taller
Yeah,
in the
in the
morning.
morning or
So we're looking at greater than 0.
Yeah, okay. I got
So greater than, I get 1.39, but E minus 24. So it means that it's 0.
oh.
Do you get that?
no, I didn't understand.
What do you get? So I get, for the p-value, I get 1.39734 E minus, yeah, but it's like E minus 24. So it means that it's
Basically 0.
elevated, like it's multiplied by 10 at negative 23. So it's like 0.
No sé, creo que mai avuto un 0 come p-value. Based on your results of this test, is there enough evidence to suggest that the children are taller in the morning than in the evening?
Yes,
because we reject the null hypothesis. So the third one. Okay, I'm gonna submit, you guys.
Okay.
Wait, okay.
Aspettiamo live. Mettiamo live. Okay, we missed 5. It's not too bad out of 43. I mean, still 88.37%. I may just accept this grade and leave now. Just kidding.
Let's check which one.
Okay. I saw it. Okay.
Can we start from question 2?
From question?
Yep.
Yes, okay. I was actually going backwards. So yeah, let's start from question. Okay, I guess question 1 is true. Question 2 is correct. Question 3 is correct. 4 correct. 5 correct. 6, it's okay. 7, okay. 8, okay. 9, okay. Wait, where are those? 10, okay. 11, okay. 12, okay. 13, 14, okay. Okay, question 15 is wrong. All 15, 16, 17. Let me all be there. Yeah, so it's starting from the 15th that they're wrong.
So all the, like, let's say like
Values,
15
16
to 17.
The 18 is correct,
Uh-huh.
but the 19 is wrong, and the 20 is wrong, and the 21 is wrong.
Huh.
So we just did that.
So we just
the whole
made-
exercise.
The whole
wrong.
exercise is wrong. Yuppie. All right. So
Pretty
you
sure
said-
it's Daniel's fault anyway.
You said we started from question
15. How do you say 15 in Spanish?
15.
15. There we go.
15.
15.
So, use the following information. The next question. Acupril is meant to control hypertension. In clinical trials, subjects were divided into 2 groups. Certain group received Acupril. Ah, okay. I think I know where I did it wrong.
I don't.
Because I put 1,563 for N2, but N2 it's
No,
579.
it's 579.
So it's 61 over 1563, right?
It's 61 over 1563.
And it's 15 over 579.
Yeah.
Okay.
15.
So that means that, let me close this. Just a sec.
Huh.
So that means
My
that
bad.
question 15, right? It's the first one that was wrong. Well, Excel does it, you know.
Yeah.
It's like a spreadsheet.
We just input the wrong numbers.
Yeah.
I told him the wrong number.
So,
Where did they say margin of error?
what?
You should.
It's the 2 proportions, like the categorical data analysis spreadsheet.
Yeah.
And you
Yeah,
take the 2 proportions. You put X1, it's 61. N1, it's 1563. X2, it's 15. N2,
579.
it's 579. And then we have
Yeah,
the confidence. We have the confidence interval that it's negative 0.003 and 0.029, and we need to find the margin of error. So it's and it's 0.016. Zero point zero 0.016. Did you get to the upper bound minus the lower bound, and the result you divide it by 2, because doing upper minus lower, you get the whole distance, and then you know that the mean is going to be in the middle, and so the margin of error, it's going to be the same distance, you know, so you just divide by 2, and so that's how I get 0.016. So the lower bound is negative 0.003. Negative 0.003. Then the upper bound is 0.029, 0.029. Then 18 was right, because we got that right. Then 19, the value of the test statistic, it's 1.458. So did you get 19, 1.458? Yeah. Then 20, it's 0.145.
Yes. And
then at that point, we're not rejecting the null hypothesis.
So we failed to reject.
No, I failed to
So the last one.
reject. Yeah. Is there anything else wrong?
I do not think so. I'm checking right now, but I'll say no, it's everything correct. Yes, everything correct.
We just messed that for like a stupid
Error
of just
typing
putting
the
one,
data.
one number instead of the other. So that's pretty cool.
Yeah, it means we got the procedure.
Methinks it's good. I'm submitting.
Are you all thinking that? My God, Helma.
Let's see if it's right. Yep.
Good
All good.
job.
If you want to stop the recording, easy.
Well done. Cosa faccio? Cosa faccio? Lesson 20.